Hello everyone! So we're going to be reviewing Chapter 7 starting today, and let's go ahead and get started on that, and going through some word problems. I know in class we normally skip kind of past word problems or only do a couple, but I really think that as we're doing the video lessons now, this is going to be the best way for us to review how to do some of these problems for you to understand what it is that you're doing in some of these problems. And it adds a little for me because I have to read them out to you a little bit. So as the video goes on, we'll see how this works. Please let me know if this is how we should do reviews from now on. We're going to start here with this problem. It says that the town of Oyster Bay is conducting a survey of 80 households to see how prepared its citizens are for a natural disaster. Of those households surveyed, 66 have survival kits at home. Write a ratio of the people with survival kits in the survey. Okay. That's problem number B says write a ratio of the people without survival kits in the survey. And problem C says there are 29,000 households in Oyster Bay. If the town wishes to purchase survival kits for all the households that do not currently have one, predict the number of kits it will have to purchase. So we're going to start with A here. It says write a ratio for the people with survival kits in the survey. So the first thing that we need to do is we need to take our information. We have 66 survival kits and 80 households. So we set up our ratio now of 66 over 80. But that can be simplified. Notice that each of these can be divided by 2 to 33 over 40. Or if you did it on a calculator, you may have come up with 0.825. Because we're working with cross products and cross multiplication in proportions, you're gonna need to learn how to do it in a fraction like this because we're going to be using these numbers later on. Doing it like this may get you an answer for one problem, but it's not going to help you down the line when you have to use that information later. So the correct answer for A is 33 over 40. Let's do B now, where it says write a ratio of people without survival kits in the survey. So the first thing that we need to do is say that, if 33 out of 40, that's the ratio that we came up with, do have survival kits, then we have to find out how many don't have them, and we can do that through subtraction. When we say that 40 are the number of people, 33 of them have a kit, so we do 40 minus 33, and we end up with 7 without a kit. So our next ratio of those without kits will be 7 over 40, or 0.175. All right, so 7 over 40 is the answer for B. What about C? Well, it says that there are 29,000 households in Oyster Bay. If the town wishes to purchase survival kits for all households that do not currently have one, predict the number of kits that it will have to purchase. So this time we're changing up the total number. Remember, this is just a rate. This is a unit ratio that we figured out that we can now use to determine what if we have a large number. Remember all the way back in video number 1, we talked about unit ratio. We talked about the apples or the candies. If you had so many green apples, so many red apples, what if you had 1,000? What if you had 2,000? Well, this is one of those cases that, well, what if we have 29,000 households? Then how many would we need? Given this ratio that we have here, we say that there are 7 that don't have it out of every 40. So what if we have 29,000? Then how many don't have it? How many will we need to buy so that everyone has one? Okay. So let's set up our proportion. We have 7 over 40, that's how many don't have a kit, equals, and we're using our 29,000 total here, and we're trying to solve for x. X is the one we're looking for, so that just remains as the variable over there. Then what we're going to do is we're going to cross multiply. Notice that we've been doing this a lot. I hope that you guys are getting lots of practice in cross multiplication. So you end up with 40 times x, which equals 203,000. Then we want to isolate the variable, and the way we do that is by dividing both sides of the equation by 40 so that we get x by itself. And you'll find out then that x equals 5,075. Okay, so if you want to take your time looking at these, you can always pause the video because I'm just going through and kind of explaining them. Make sure to try these on your own before I go ahead and go through each of the answers. That first one went by pretty quickly, so if you need to pause the video, take a look at the question, do kind of what we did before. Read through it and figure out what you think the answer is going to be before I give you the spoilers here. So let's read through. Number 1 says panels. When closed, an entertainment center is made of 4 square panels. The 3 smaller panels are congruent squares. What is the scale factor of the larger square to the smaller squares? So let's take a look at this problem here. This is kind of what the entertainment center looks like, or a representation of it. We've got places over here for DVDs, for CDs, if anybody even has those anymore. Stuff that you can put to go next to a television. I think most people will probably have their TV up on their wall or up on top of a shelf like this now. But this is kind of a classic system. What we're looking at is we're trying to figure out what the scale factor is between these smaller squares and this larger one. Take note that there are 3 of these and 1 larger one. That's going to be important for figuring this out. Go ahead and pause here if you want to figure it out before I explain the problem to you. The next slide will have all the spoilers. Okay, so here we have the same problem with a few of my markings added in here. We have 1, 2, 3 smaller squares. We'll notice that I've put this green lightsaber bar over here to show the line of this side of all 3 of the squares put together. And I put the red lightsaber line, these red line over here, just to indicate this side, or side A, of the larger square. And I wanted you to notice that they are congruent, that they're the same length. These 3 adds up to the side of this 1. And because this large square is a square, A is equal to B, which is equal to D, which is equal to C. So it's going to remain true even if you add up the different sides of these smaller squares. Add up their 3 sides and they'll equal one of the sides of the larger squares. So it is like multiplying by 3 to get this length over here. You multiply the smaller number by 3 and you get the length of the larger side. So the scale factor is a factor of 3. Next word problem. An official Olympic-sized ice hockey rink measures 30 meters by 60 meters. The ice hockey rink at the local community college measures 25.5 meters by 51 meters. Are the ice hockey rinks similar? Explain your reasoning. Okay, again, if you want to pause right here, you want to take a shot at this on your own, please do so now before I give you the answer. Okay, so the first thing that we want to do is we want to set up our proportions. When we set up the 30 over 60 that we're given in the first one, we can reduce that down to 1/2. Our second set of information, 25.5 and 51, can also be reduced down to 1/2. Now, because these are the same ratios, that means that these figures are similar to each other. Next, enlarging. I've actually drawn in on this one because this type of thing, I just want you to get the concept of what enlarging does. It says Camille wants to make a pattern for a 4-pointed star with dimensions twice as long as the one shown. Help her by drawing a star with dimensions twice as long on the grid below. So we start with this star here, and we can figure out that if we count this right here as the center of our star, that if we count out 1, 2 spaces here, that reaches the top point of the star. Go to the right 2 spaces, it's the right point of the star, and so on and so forth for every point on the star here. It's 2 spaces away from the center of the star. So if we want a star that is twice as big, we say create the center here on the grid, then we go up 4 spaces to find the point on the star in each direction. Each of the cardinal directions, we'll put that there. And if we had any sort of coordinate points here, what we would do next is we would actually try and find slopes for each of these lines to then draw them appropriately in there at the right angle. Since we don't have that, I've just given you the endpoints and I've kind of built in the star here so that you can see what happens when you enlarge something on a scale. Think back to the rectangles, excuse me, the squares that we just did. We did that on a scale factor of 3, and that square was 3 times larger than the other smaller squares. So if we enlarge this by 2, then this is twice as large as this figure over here. So just keep that in mind, and let's go ahead and move forward to our next problem. Our next problem says that a paramecium is a small single-celled organism. The paramecium magnified below is actually 1/10 of a millimeter long. So problem number A says that if you want to make a photograph of the original paramecium so that its image is 1 centimeter long, by what scale factor should you magnify it? Question B says, if you want to make a photograph of the original paramecium so that its image is 15 centimeters long, by what scale factor should you magnify it? And we're going to go ahead and skip C here. C would actually need you to take out a ruler and measure the drawing there, but since I've already blown up the picture, that's a little bit ruined. So the first one says, if you want to make a photograph of the original paramecium so that its image is 1 centimeter long, by what scale factor should you magnify it? Again, if you want to take a chance at this on your own, go ahead and pause here, work it out on your own, work out A and B, and then come back for the answers in just a second. Okay, the first thing that we have to keep in mind is that a millimeter is 1,000th of a meter, and that a centimeter is 100th of a meter. 1/10 of a millimeter is 0.1 times 1,000, which is 100. So the answer to A is 100, and let's go ahead and move on to B now. B just says that if you want to make a photograph of the original paramecium so that its image is 15 centimeters long, by what scale factor would you magnify it? Well, this time we did 100, and we said if we want 15 centimeters, notice we're changing from millimeters to centimeters here. Now we're saying, what if it's 15 centimeters long? So we're just going to multiply our number here by 15. We end up with 1500 as our scale factor that you magnify it by. Next word problem. A radio tower casts a shadow 8 feet long at the same time that a vertical yardstick casts a shadow ½ an inch long. How tall is the radio tower? Okay, again, if you want to pause and work on the problem on your own, please do so now. All right, so I've drawn in here the information that we're given. I have not completed the triangles like we normally would. I've just given you the vertical, the horizontal of both figures. Vertical and horizontal of both figures are here on the problem, and as I've written in here, it's not drawn to scale, so don't get mad at me that this 8 feet is actually not much bigger than this ½ an inch over here. And this 1 yard is not a yard. None of it makes sense. It's not drawn to scale. So what we're looking at here is we've got a shadow of 8 feet off of the building, the tower, right? And we've got a shadow of ½ an inch off of the yardstick. So we've put in place here the 8 feet for the shadow length, 1/2 inch for this shadow length. We've got 1 yard as the height here of this yardstick. and we're looking for x. We're looking for the height of this building, how tall this building is that casts an 8-foot shadow, while at the same time a yardstick would only cast a half an inch shadow. So let's take a look. Again, if you want to work that out, you can stop there. If I've helped you set up the problem and now you know what to do next, you can go ahead and pause me again and work it out and see if you get the right answer here. So step 1, we want to convert it all into the same units of measurement. So there are 12 inches in a foot. Remember that we were given a figures with feet, yard, and inches in it. So we're going to have to convert them all to something that we can use for each one. What I've gone ahead and decided to do is I'm going to convert them all into inches. Noticing that there are 12 inches in a foot, we can then take our 8 feet, multiply it by 12, and say that that 8 feet is also written as 96 inches. 1 yard, then being 3 feet, could be written as 36 inches. Step number 2, let's set up our proportion. We've got 96 over 1/2 inch, 96 over 0.5, and we've got x, what we're looking for, the height of the building, over 36 inches. So what do you think we'll do next? I'll bet you can guess that we are going to cross multiply. When we cross multiply, we get 96 times 36 equals 0.5 times x. So we take that 96 times 36 equals 0.5 times x. We can write that out as 3,456 equals 0.5x. But I really don't like having x on the right-hand side of the equation, so let's rewrite it here as 0.5x equals 3,456. Then we solve for x, dividing both sides by 1/2 or 0.5, and we get x equals 6,912 inches. But do we really measure buildings in inches? Do we really go around saying, oh, that building is so many inches tall? No, we really don't do that. Most of the time we're going to do it in feet. Sometimes we may do it in meters or yards. But if we're looking at the building, we could also convert this by dividing this number by 12, getting x equals 576 feet. We divide by 12 again because there are 12 inches in every foot. So 576 feet is how tall the building is. And if you really wanted to go for yards, you could then divide again by 3, since 3 feet for every yard, and we get x equals 192 yards. But really the answer that we're going for is in feet. 576 feet is the correct answer. And that is all, folks. That is all we're doing for today. This is our first half of the review for Chapter 7. Let me know if you're having any trouble with any of the worksheet problems. Please email me. I have not really heard from so many of you guys, so I'm not sure how all of you are doing. I'm looking at my emails. I see those of you that have emailed me. I'm going to get back to you soon on some of the questions that you have. It's been a super busy week. But let me know how it's going and how these things are helping. If there's anything else that you think we can do to help you guys understand, if there's stuff that you're not understanding, please email me on that. I'm going to be putting up on iGrade your test, which will be due in a week from Thursday, and I'll put the dates on iGrade as well. So make sure that you have that ready and in mind, so that you're preparing to take your Chapter 7 test and get it back to me. Again, we're doing this all through email again, guys. If you have any more questions, feel free to email me anytime. We can set up something. If the emailing back and forth is not enough interaction, if you're thinking that you need more specific, we can FaceTime sometime. We can do a Google Hangout, whatever we need to do to get you guys understanding these problems. I'm hoping that you guys are staying safe, staying healthy, and staying out of trouble. All right. Talk to you later, guys. Bye-bye.